All right, well, welcome. In this video, we're going to take a look at inheritance in object-oriented programming. So the first thing that you're going to need to do is we're going to ask you to create a new file. So if you just go to Visual Studio Code, get that open and create a new Python file. The next thing that we do, as always, is to copy our previous lesson's Python file. So I'll just do that now. And then once you have it open, copy it. And then paste it. It's also a good idea to have your driver program open and then save your new inheritance program. I'm just going to say this is OO inheritance. All right, so what we're going to do now is we're going to create a brand new class. And in this class, we're going to call it Mammal. So what we can do is we can contract all the code inside human. And just above it, we're going to create our parent class called Mammal, because a human is a mammal. It's going to look a bit like this, and we're going to add some new attributes and some methods. So as I've mentioned before, it's best to kind of be very explicit about where are your attributes and where are your methods. Just so if someone else picked up this code, it would be fairly easy for them to go along with it. All right, we're going to create a few new attributes. We're going to create an attribute called fur type, desired body temp, current body temp, and we're going to create a method called regulate body temp. And I'm about to just give you a little bit more modified an example of initializing an attribute, or at least telling it what kind of data is inside this particular attribute. Now, previously we've been doing things like this just to indicate, well, it's a blank string, but going forward, it might be better. It is better to actually define the data type like this. So similar thing, what's happening, it's just that it's actually not populating the attribute with any actual data. It's just saying that when it does get populated, it needs to be a string. So you can see how you can define the data type here. So we're going to say, well, fur type is a string, and we're going to say our desired body temp should be an int, and our current body temp should also be an int as well. All right, the next thing we're going to do is we're going to define a method. And we're going to call this one regulate body temp. At this point, I want to introduce to you a stub. Now, a stub is a temporary subprogram, and in this case, a method is also known as a subprogram or a function. It's just a special name in OO, and it's a temporary program. Literally, it just prints out, "Hey, you've entered this program." So we're not going to actually write the regulate body temp routine yet, but what we will do is we'll just create a stub, basically saying, well, this is the regulate body temp method. All right, so if someone does actually run it on in the program, they'll realize, and you could say something like this. You could say, it hasn't been written yet. So they know that it's a stub, and then you can even just say code goes down here. Okay, so that is the first step where we're creating our new class called Mammal. So I'd like you now to pause the video and get all this code down in your Python file. The second thing that we're going to do is just have a discussion around continue our discussion with private and public attributes. Now, in the past, we've talked heavily about public versus private. I'm going to introduce to you today the protected attribute. Now, so we know that public attributes are available from, can be accessed by any other class or any other object. And we know that private attributes can only be accessed by the class itself or the object itself. Now, protected is a special type of attribute that is used for inherited classes. And protected basically just means that it can be accessed by itself, by its own class, or any subclasses underneath it. So for example, let's say we did start protecting these mammal attributes, it means that because when we link the human to the mammal class through inheritance, it will still be able to change those attributes because of the link between the two classes. The answer to this problem is using protected attributes. So we're going to do that in a moment. In fact, let's just do that now. So in Python, a protected attribute is denoted by a single underscore. Okay, so we're just going to change these so that they're single underscores, and they become protected attributes. I want you to pause the video now and make sure that you've changed these attributes so that they're protected. We now move on to linking the human class to the mammal class, i.e. linking the child class to the parent class. And it's really simple. All you need to do in Python to link a child to a parent is simply put brackets just after the name of the class and type the class that you're inheriting from, and that will be the mammal class. The next thing that we need to understand is that when an object gets created in Python, we have to use a constructor. And in particular, in this case, this constructor for the human class is going to do all these different attributes, right? It's going to populate and make them all kind of be initialized. The problem with inheritance is that we have some attributes up here that won't be initialized at this particular point in time because we haven't referenced them in our constructor. So the answer to that is to create a super constructor, and so that it inherits and it initializes these three attributes at the time of when a human is being made. So all we need to do is reference this super constructor, which we've already written up here, and say, hey, when humans get made, first let's run this constructor up here and initialize these three attributes, and then go ahead and initialize all of these attributes. So to get that link going, we go super dot and then int, and that's it. All right. So at this stage, because there's no parameters in there, it will just initialize all these values. Now, what we can also do is we can override, or actually populate, should I say, if there's something specific for a human of any of these attributes. And one of these is the fur type. So humans, they do have fur, and it's called hair. Every single human, well, most humans have hair, right? And so we can say, well, by default, our fur type is hair. And we know that. And so we're going to populate that attribute. That is the first step. So I'd like you to pause this video and get this bit of code down. So what I need you to do is make sure that you've got the inheritance going, and then add the super constructor and change the fur type to be hair. The next thing that you might come across is that in a parent class, the constructor may have parameters set. So for example, we might say that in this mammal, whenever a mammal gets created, you give the option of the programmer to add the current body temp at the time of instantiation. Instead of the self.current body temp is int, we can say, well, it will equal whatever the parameter is that's being sent down. Okay, so we learned that last week, or last lesson. And so now we kind of need to replicate this kind of setup from our super class into our super constructor here that we're referencing off. In our our constructor for our human class, we firstly now need to make a mention of we're expecting them to put in our current body temp. All right. Now we then need to say, well, hey, where does this go, sorry, that shouldn't be an underscore. Where does this go? When they type the current body temp, once the human's being initialized, when it's being born, for example, where does that go? Well, it goes into the super constructor, because once it gets fed into the super constructor, it will then be sent down and saved as an attribute here. So in here, what we need to do is put a reference to that particular parameter that's been set. And so if I run this now, of course, nothing happens, right? What I need to do now is update my driver. So let's go ahead. I'm going to update my driver. Now, the first thing is that I'm not importing from the encapsulation file anymore. I'm importing from the inheritance file. Now, if I run this, it will still work. However, what's happened is the name has been replaced by 50. Why? Let's have a look. Let's go all the way back and start creating a new human. Now, if we have a look here at the time of instantiation, what we are looking at here is all the parameters that need to be set. And as you can see, the first thing that is expecting is the current body temp, because that's the order in which I have now presented these parameters. Now, order matters. So I now need to put the current body temp of this human. So let's say it's 36.5. And now if I start saying Tobias, John Paul, Jakes, now again, if I run this, I get a better data set, but I still don't get to see what his current body temp is. How do I change that? Well, I just got to make sure that when I print all my attributes, that there is some sort of reference to that current body temp. So if I just put current body temp, and then I go self dot current body temp, and then notice the 1 underscore because it's a protected attribute. It's not a private attribute. And I'm just going to, yep, so that's good. Save that. I'll now run my driver program again. And you can see here the current body temp is now being populated with that 36.5. So we now have a working constructor that's coming from the parent class, populating all the attributes of these new inherited attributes, which is fantastic. So what I need you to do now is firstly, in a moment, pause the video. What I want you to do is to make sure that you update the constructor in the parent class to be accepting a current body temp and updating the current body temp. And then in your human class, where there's a constructor, add a parameter in that you're expecting to see a current body temp. And then in the super constructor, send it down to there. Then once you've done that, make sure you've got it all working by using the driver program and re-entering a new human in, and make sure that you do update your print attributes as well. This is all well and good, but unfortunately, we are violating the encapsulation principles. Because what we have done is effectively directly edited from the human class the mammal's attributes. Even though we are somewhat inheriting these, by definition, it's not clean. And so really, it should come down to each object should be editing or reading its own values. Only methods in that class should access them. So we can deal with this other than using getters and setters. There is another way in Python. And that is to use the @property tag and the at setter tag. So what I'm going to do is just copy a bunch of code right now, and I'm just going to create this in my mammal class now. So I'm just going to call this the properties and setters. So I've prepared these properties and setters previously. Let me run through how they work. And I'm going to use the setter as an example. Okay, so let's say that in our human class here, we want to set the fur type to be hair. Essentially what we would do is we would say, because we cannot directly access fur type, we're going to call it just self.furType. What it's doing then is it will then scan for anything that is in the parent class fur type. And it will look and it'll say, well, there is no fur type. There's only underscore fur type. So then it will look at the properties and the setters to see if there's any fur type. And it finds that, hey, you've called something a fur type. So it's now listening. And now in this case, we want to set the value to hair. So it's going to pick up out of the properties and the setters, it's going to pick up, hey, we're going to use a setter here. Okay, and so then the parameter that you've put in here, hair, will be then sent, will be come across as the value here, hair. And then it will run this line of code. It will basically say, whatever you've put in, which is hair, we're now going to update our protected attribute, which only the mammal class has access to, will then update. And so that's kind of how properties and setters work. Now I'm just going to fix this up. Looks like there's an indentation error there. And so basically what it means is that we do need to now update our any reference to underscore fur type or underscore desired body temp or underscore current body temp. We need to make sure that we update those references. So I know I've got a reference here, and then I know I've got a reference in my print statements as well. So I'm just going to do that. Now let's save this and go back to our driver and run this again. In fact, let's just kind of change this to be 38 just to make sure that we're seeing new data coming through. And we can see that with those changes, it's still working as expected. However, what we have now done is conform to the rules strictly, in the stricter sense, of encapsulation. Because only here, the mammal class is editing its attributes. So what I'd like you to do is I'd like you to pause the video, and I'm just going to leave this on the screen here. I want you to create the three property and setters for the three attributes. So you're going to have a property for fur type, desired body temp, and current body temp. And you're going to have a setter for fur type, desired body temp, and current body temp. Then what I'd like you to do is just update your code in your human class to reference self.furType, not underscore fur type. And then once you're done, unpause the video. All right, so I guess we get turned down to the final part here. And we've looked at inheritance, we've inherited attributes, we're following the convention of encapsulation here, using properties and setters instead of getter and setter methods. All right, so we are going to update this method with some code. So I'm just going to remove this. I'm going to make sure that I've just got, this is the regulate body temp method now. And I'm going to use some sort of while loop that says, look, while, say self dot current body temp is not equal to self dot desired body temp, all right, while it's not equal to that. And you'll notice that there's a squiggly line here to say, hang on, there's no self. And you may have figured out that we haven't sent the self into this method yet, and so it wouldn't work. The other thing that is interesting to note here is that we are referencing the property tag. We aren't referencing the attribute directly. The reason why I've done that is that this is a public method that will be used by classes and objects. Because I have this written, I may as well use these and feed it through here, which will then take it down into the private or the protected attribute. I'm then going to say something like, well, if the self.currentBodyTemp is greater than the self.desiredBodyTemp, we need to bring the temperature down. Okay, so we could say self.currentBodyTemp equals -1. We could say else if self.currentBodyTemp is less than the desired body temp. We could say we want to increase the body temp by 1. And then at every iteration of this, let's print what the current body temp is so we can see that it's going down. We can now use this after I print. I might just get rid of that, and I might say human1 dot, just make sure we save this, human1 dot regulate body temp, and let's make Tobias's temperature 40, so it's quite high. And so what we should see is it basically start lowering down to 37. And so I run it, and I am getting a error. So let's try and figure out what's happening here. All right, so in this case, what's happened here is I've never set the desired body temperature, and so it's struggling to do this computation because there is no desired body temp. So what I could do in my human class is basically say, well, the desired body temp in humans is 37 degrees. All right, so let's save that now, and let's try and run this again. And you can see here that that initially Tobias's body temp is 40. But as we start regulating his body temperature, it goes all the way down back to 37, and then it stops, okay, because we're back to 37. And so that little issue here, why that didn't work, was there was no desired body temp. And so the answer to that is, well, let's do this in the human class, because hey, this is where inheritance really comes in, because every animal is different. Every animal have a different desired body temp, or every mammal will have a different desired body temp, and so we can change this in the class itself that it's related to, which is the beauty of inheritance. So I want you now to pause the video. I would like you to write the regulate body temp routine, subroutine, and then I'd like you to make sure that you initialize the body temp to be 37 degrees, and then go to the driver, save it, and then go to your driver and make sure that the method is working. So in this video, you've created a new class called mammal. You have inherited those attributes from the mammal class into the human class. We've discussed private, protected, and public attributes. We created protected attributes. We discussed the true, I guess, the best case scenario of encapsulation using properties and setters. And we started making our program useful by creating a method that did something. All right, in the next video, we're going to take a look at polymorphism. So check it out in the next video.